In this session, we shall find out what a headless version of a browser is. We will use Chrome browser to demonstrate how to use a browser without an interface to accomplish browser automation. We open a WebDriver test script on Visual Studio Code. Before proceeding, we can observe that there are multiple wavy lines on various parts of the code. This line indicates an error. It seems like Visual Studio Code could not find the libraries that we are trying to import. But it's not an error on our part, however. It is caused by Visual Studio Code running in restricted mode. So on the bottom left part of the window, we shall click on the restricted mode prompt, which opens a tab. Apparently, Visual Studio Code does not trust the sources of the files in the current window. So we click on the trust button to tell Visual Studio Code to trust this file. Now Visual Studio Code will confidently allow our imports. Note that this section is meant to simply show what a headless browser is. We shall get into the intricacies of the code in the latter sections, so do not worry about the code for now. So firstly, we shall change the target URL to the one of our course material. Then create a variable welcome_note that will get the inner HTML of the element specified in the quotes. Visual Studio Code underlines an error in our code, so we make an import for the by class. Then we can have Python output the value of the welcome notes variable. Instead of the browser quitting immediately, we can have it stay around for 10 more seconds, hence the time sleep function. And we make an import for the same. When we run the code, Chrome browser fires up and browses to our website. Besides the desired output, we also get a series of additional error information. The errors are unrelated to whatever we are doing. These are USB and Bluetooth errors. We will see how to handle them shortly. To remove the errors, we make another import for options. We shall discuss later in detail what this import does. Now we shall test the Chrome headless browser. To do so, we'll add a property .headless and set it to true. Next, we will give the virtual browser a 1600 by 900 screen size. This is in pixels. When we run the code, we get our output. We will run our code on a visual browser again. It is apparent that the USB and Bluetooth errors are tagged to the visual browser mode. In order for us to avoid these errors, we shall use the add_experimental_option method with the exclude switches name and a value of enable-logging. So when we run our code, we get the desired result and a clean terminal. Remember, we shall look into detail what all these lines of code do. For now, we've discovered what a headless browser is.